Hello, we are going to be discussing properties of exponents. This is going to be a great video to review all of the properties that have been discussed. So we're going to talk about the zero law of exponents, negative law of exponents, multiplying powers, dividing powers, and power of a power properties. We'll see some examples from each one of these properties and how to compare exponents or to solve given the question that we've been provided with. So let's take a look at this first example here. This first example says in the following equation, what is the value of z? And so we can see here that z is this exponent that's attached to the base number of the numerator. We have to think about what our properties of exponents say. And when we look at this part here, the 6z over 6 to the third power, we can see here that this is where we have dividing powers, okay? So we have the base, we have the same base actually in this case. We have a 6 in the numerator and a 6 in the denominator. And so what we can say from here is we can actually say that the base will stay the same. But now what we can say is we can take these exponents here. So we can take z and we can subtract 3 from it. And what we should get from this equation is we should get 6 to the power of 2. Now, the question's asking us, what is the value of z? Since we've kind of already set this up and we've identified what property we're going to be using, we can actually just look at this part right here now, z to the z minus 3 and then 2. And we can set this up as an equation. We could say z minus 3 is equal to 2. Okay, and now what we want to do is we want to figure out what number can we replace this variable with in order to make this a true statement. And if we think about that, we can say that if we plug in this number 5, we can say 5 minus 3 would give us an answer of 2. Okay, so with these kinds of questions, we have to set it up first, and we have to figure out what property we're using. We have to figure out with that property, how would we set it up with using addition, subtraction of our exponents, or how would we combine those exponents? The next example we're going to look at is going to be slightly similar to that one that we just saw. But in this case, now we're looking at this and we have two variables that we're working with. So we have 4 to the third power is equal to 4 to the m power over 4 to the n power. And again, we are in this equation, we are dealing with the property of dividing powers. And so that's where we can take these exponents and we can subtract them. And so in order to set this up, the first thing that we want to do is we want to take this side with the division problem, and we want to set this up where our exponents are written where we're using that property. So set it up as a single power of 4. So we know the base here is the same, and so we're just going to leave that base as 4. And now the division, when we're dividing properties, again, we're going to take the exponents, m and n, and we're going to subtract them. Okay. And so now that we've kind of set this up, we can actually say, we could take just the exponents here. So we could take 3 and we could take m and n, and we could set this up as a separate problem. So 3 and m minus n. And we have to think about what numbers can we plug in for m and n to make this a true statement. And when we think about it, we have to get to 3. And so in this case, we want our number, the bigger number that we're subtracting the other number from, we want it to be larger than 3. So we could say, okay, 4 is larger than 3. And then we can say that 4, what can we subtract from 4 to get to 3? And we could say that would be -1. And so when you're working with these kind of questions, we can pick, in this case, since it is subtraction, we would want to make sure that we say that 4 is our value for m and 1 is our value for n, because if we did flip them and we did say n is 4 and m is 1, that's actually going to change our problem because we have m in the numerator and n in the denominator. We have to make sure it's set up with m minus n, or the number in the numerator minus the number in the denominator. So we do have to make sure that we do keep those numbers matching with those variables and that they do match when we plug them in. All right, so let's look at another example. This is going to be a different kind of example now. Again, a really good review with properties of exponents. So we need to figure out which two expressions are equivalent to each other. It's very important when you're looking at these questions that we are reading the question carefully, because in this case, we want two answers, okay? And so we might be looking at this and we might say, okay, here's an answer, but in this case, we have to figure out the two that are equivalent. So we're going to have a multi-select question where we have to select two answer choices. Okay. So let's break this down a little bit. Let's look at this. So in order to find the two expressions that are equivalent to each other, we need to take each one of these expressions and write them to where they have the same base. Okay. And remember, the base is that number that is the larger number. So in this case, it looks like most of them have the base of 8. And so that's what we're going to kind of stick to, is we want to make sure that all of them are written with a base of 8. And so we're going to use the properties of exponents, and they're not all, like in the last couple questions, we used the dividing property. We're going to use different properties in this type of question because there's going to be different, we want to convert each one of these expressions. And so each one of these expressions are written differently. So it's not always going to be the same property that we're using. Okay, and then once we convert each one of these expressions, that's where we can pick the two that are the same. So I'm just going to label these. I'm going to say this one is 1, this one is 2, this one is 3, this one is 4. And this will make more sense why I'm labeling them as we are answering this question. So the first expression that I'm going to convert is going to be answer choice 1. Okay, and answer choice 1 says we have 8 cubed, and then on the outside of the parentheses, this is to the third power. So we have to figure out, first of all, what property are we using? And when we look at this, this is actually the power of a power property, which tells us that those exponents, we can actually multiply them together. Okay, the power of a power property says that if we have our base here, and let's say we have an exponent of x, and then on the outside we have the exponent of y, we can say that our base stays the same and we multiply x times y. And that's exactly what we're going to do with this expression. Okay, so our base is going to stay the same. And then what we're going to have is we're going to take 3 and multiply it by that other exponent on the outside of the parentheses. So 3 times 3, which would convert this expression to being 8 to the power of 9. Now, we're not going to continue, we're not going to solve this exponent for a large number because we want to convert each one of these to where they have the same base and they're written as such with the base and the exponent, and not in the form of having those powers or those properties associated with them. So in this case, we're just going to leave it as 8 to the 9th power. And that's the first expression. So now we've done that one, we're going to move on to the second expression. The second expression we have is 8 to the 5th power over 8 to the 11th power. And we did practice a couple examples with dividing powers, so we can see that this is going to be our dividing powers property, where if we have a the x power over a to the y. We will actually keep the base the same, and then we'll take the numerator and subtract the denominator. So we're going to do that with this question too. The base is going to stay as 8. And now we're going to have 5 minus 11. In this case too, looking at this expression, we have to make sure that we keep the numerator as the first number minus the denominator. So in this case, it would stay as 5 minus 11, which is going to give us a negative number. It's actually going to give us an answer of 8 as our base, and then 5 minus 11 would be an exponent of negative 6. So these are the first two expressions that we've done. Got it almost halfway there. And we are going to move to expression number 3. And this is why I labeled them as well. It's going to keep me much more organized, make sure that I'm, when I'm converting these expressions, that I'm keeping them with the original expression with that property so that it's easier for me to make my selection when I answer the question. So now I have an expression of 8 to the 11th power over 8 to the 5th power. And again, this is the dividing powers property. So we have a to the x over a to the y, and we would say that a is our base, and we would take our numerator and subtract our denominator. So now our base stays as 8, and now we can say, okay, now we have 11 minus 5. And this is where it's important, because if in the last expression we had flipped it and said 11 minus 5, then it would look like these two expressions are the same, and they're really not. Okay, and that's going to give us the answer of 8, and 11 minus 5 is positive 6. Now, when we look at these two answer choices, we have 8 to the negative 6, 8 to the positive 6. Those are not the same. Okay, remember those negative exponent rules are still going to apply. So those are not the same expression. And then lastly, we have this one here. We have 8 cubed, 8 cubed. And when we look at this one, we can say that this is our property of multiplying powers. Okay, and what that says is if we have a to the x times a to the y, we would keep our base the same, and x plus y. And so when we look at this, we would say, okay, so our base stays is 8, and then we would take our exponents of 3 plus 3, and then we can have a final answer of 8. 3 plus 3 would give us 6. So now that we've converted each one of these expressions using the property that is associated with it, we can see clearly which ones are going to be equivalent to each other. We can see that this one here, I'll change the color here, go with blue. This one here and answer choice 3 and answer choice 4 are going to be equivalent expressions. They're going to be equal to each other, even though they're not set up the same way. When we finally use those properties of exponents to convert them, we can see that they are going to be equivalent. It does seem like it's a lot of steps, but it is very important to follow those steps because, and to stay organized, because it's going to make answering the question a lot easier. Okay. Let's move on to another example here. This is going to be another similar type of question you're going to see, where it says tell whether each expression in the table is equivalent to 5 squared, 5 to the negative 2 power, or neither. And so again, this is going to be one of those types of questions where we have to rewrite each one of these expressions to see which one is it going to be equivalent to. Okay. And so the first one that we're going to use, first one that we're going to look at is 5 to the negative first power. And then we have on the outside of the parentheses, we have a 2. So I'm going to label this as 1, just like we did before. So again, this is going to be that property where we have, and I'll write this off to the side, we have the power of a power property where we have a we'll say to the x, and then on the outside we have y. And so this could be rewritten as a to the x times y. And so we can look at this one and we can say that we have 5, and then our exponents are -1 and 2. And so -1 times 2 is going to give us 5 to the -2nd power. So this would be what it would be equivalent to. All right, and then moving on to number 2, we have 5 to the -1st on the inside, and then on the outside of the parentheses, we have a -1 as well. So again, this is going to be our power property, where we will be multiplying those exponents together. So our base will stay as 5, and then our exponents would be -1 times -1. We have to remember those rules of integers as well. Those do not go away. So we have to remember when we're multiplying, if the signs are the same, your answer is positive. And then if the signs are different, your answer would be negative. And so -1 times -1 is going to give us a +1, which when we look at our answer choices, we have equivalent to 5 to the 2nd power, equivalent to 5 to the -2nd power, or equivalent to neither. And so in this case, answer choice 2 would not be equivalent to either 5 to the 2nd power or 5 to the -2nd power. All right, moving on to expression 3, we have 1/5, and then on the outside of the parentheses, we have squared, which actually is telling us that we have 1 squared over 5 squared. Remember, if it's outside the parentheses for that fraction, it's going to go with the numerator and the denominator. Okay, and so in this case, we can actually say that this is going to be a little bit of a different property. It's going to be the negative law of exponents, okay, in order to convert it. And so we know that 1 squared is just going to be 1, but then what we want to do is we want to write this as a base of 5, because that's what we can see here, is we've got these bases of 5 with each of these numbers, and that's what we're comparing it to. And so in order to do that, we're going to look at that negative law of exponents, which tells us that if you have a number, and let's say you have a negative exponent, that's where you would flip the exponent. We would say, okay, 1 over x a to the x power. Now it can work the other way around as well. So let's say we have 1 over 5 squared. We can convert this and we can say, okay, bring this to the numerator. But in that case, we have to make sure that we're completing the proper transition with the exponent. And so if the 2 was positive in the denominator, it's now going to be negative in the numerator. Okay, remember, you're flipping those fractions. So while the negative law of exponents is telling you that if you have a base and then a negative exponent, you'll flip it, and that's how it's positive. The same rule applies if you want to reverse it and you want to bring that exponent to the numerator. If it's in the denominator, bring it to the numerator. If it was a positive, it would then be a negative. If it was a negative, then it would be a positive. So it's kind of opposite. So in this case, we have an answer of, this would convert, I'll write this over here, 5 to the -2nd power, okay? Just like we said, 1 over 5 to the 2nd power is positive in the denominator, and so to bring that 5 as the main base to the numerator, we would have to take that exponent and make it a negative. So that would mean that this is going to be equivalent to 5 to the -2nd power. All right, and last we have 1/5 to the -2nd power on the outside of the parentheses. And so in order to do that, we're again going to look at that negative law of exponents. And so one way we can do that is we have negative, we would rewrite this as 5 to the -1st power. And then on the outside, we could say to the -2nd power, okay? And so the reason why we could do that is because we brought that 5 had the -1, or I'm sorry, had a +1, and in order to bring that to the numerator, we would change it from a positive to a negative. And so this is kind of an easier way to write it, especially in this circumstance, where we can then use the power of a power rule in order to figure out what is it equivalent to. Okay. And so this is where we can see that we have our base, and then we have an exponent, and we would say our base, we could say those exponents times one another would help us to convert that question. So our base would stay as 5, and then we would take these exponents, -1 times -2, which would tell us that this would be 5 to the positive second power, +2. And the reason why is, remember those integer rules, if the signs are the same, that means your answer will be positive. So -1 times -2, they do have the same sign, so it's going to give you a positive number. And then 1 times 2 is 2. Okay. Um, so again, for questions 1 and 2, we mainly use the power of a power rule. And then for 3 and 4, we kind of incorporated the negative law of exponents as well as the power of a power rule to that question. And so with this type of question, you want to just go through, again, we're going to convert each one, and then we're going to make our selection based on the question. And it's okay to select equivalent to neither if it's not going to be equivalent to either one. The most important thing, though, is we want to make sure that we are rewriting our expression to have the same base as what they've given us in the question, because it will be easier to compare to see if they are equivalent. Okay. For instance, if we just looked at this first expression and we said 5 to the -1st power, and then on the outside of the parentheses we have a 2, it's a little bit more challenging to see that, yes, it is equivalent to 5 to the -2nd power if we just left it that way. So it's much easier to see if we rewrite it. All right, and then last question we have here is we want to put the expressions in order from least to greatest. Okay, so least to greatest means that the first number that we have is going to be our smallest number. Now, this is not accurate just yet because we haven't answered the question, but this is where the smallest number should be. And then the largest number is going to be at the end, or the greatest number. So smallest to largest, least to greatest. In order to do this, again, we're looking at these numbers, these powers, these bases with their powers, and none of them really kind of match unless we went through and we were converting them to their whole numbers, but it's much easier just to convert them to where they have the same base, okay? So we want to write each expression with a base of 4, and we want to make sure we have a positive exponent associated with it. And then we'll put the expressions in order. So the first one, and I'm going to label them again because it's easy for me to just keep organized if I have them all labeled. So 1, 2, 3, and 4, even though these are not the answers. But then what I'm going to do is I'm going to come over here and I'm going to say, okay, I want to rewrite my first expression, which it would be 4 to the -4th power. Then on the outside of the parentheses, I have 3. So this is where we're going to go back to that, our laws of exponents, and we have the power of a power rule where we have a x inside the parentheses and then y. So this is just going to tell us we're going to take those exponents and multiply them. Okay, so the base stays the same, 4 stays the same, and then we're going to take these exponents, -4 times 3, and that's going to give me an answer of 4. -4 times 3, integer rules again. The signs are not the same this time, so that means our answer is going to be a negative number, and then 4 times 3 is 12. Now, the one thing we want to keep in mind with this is that we want to have a positive exponent, okay? And so with this, we're going to convert -4 to the -12th power to a positive exponent by using that negative exponent rule where we say, okay, if this is in the numerator, now we're going to bring this to the denominator, and it's now positive, and we're just going to place 1 over top. And I'm going to write this. I erased that chart over there because I want to put this here so that we can see exactly what the order we have with these exponents. All right, and then the next one we have is going to be 2, which is 4 to the 15th power over 4 to the 5th power. So when we look at our laws of exponents, this is going to be that law dividing powers law, where we say we have a base, say x to the x power, and then we have a base to the y power. And so what we can say is we can keep that base the same and take those exponents and subtract them. Now, when we do that with our question, we have to keep the base the same, which is 4. And then we're going to take the numerator, so the number in the top, so 15, and then we're going to subtract the number in the bottom, which is 5. So 15 minus 5, and this is going to tell us that our base will be 4, and then 15 minus 5 will be an exponent of 10. So 4 to the 10th power. All right, and then expression number 3, do this one over here. We've got 4 to the negative 4th power times 4 to the negative 5th power. And so when we look at our laws of exponents, this is going to be the multiplying powers property, where we have our base, we have our exponents, we're multiplying these together. And so we would say our base is going to stay the same, and then we would just add those exponents together. So x plus y. When we do that, we're going to have 4 stay same, and then our exponents are negative 4. We're going to add negative 5. And so in this case, we have 4, and then negative 4 plus negative 5 is negative 9. And so again, we want to keep those exponents as positive numbers. And so we're going to use that negative law of exponents, where we have 4 to the negative 9. This would be in the numerator, and so we'd have to drop this to the denominator. And then when we do that, it would become a positive. Okay, and when I say it's in the numerator, we have to imagine that this is over an imaginary 1. So it's kind of just like we were upstairs and now we're moving downstairs, and then the 1 is going to flip as well. All right, and so expression number 3 can convert to 1 over 4/9. And then number 4 over here, we have 1 over 4 to the negative 12th power. In this one, we're just going to use the negative law of exponents because we have this negative exponent in the denominator. So again, when you have a negative exponent, whether it's in the numerator or the denominator, you would flip it to the other one, and that's where it would be positive. So in this case, this 4 to the negative 12 is going to move to the upstairs, we could say, okay, 4 to the 12th power now. And we could also move this 1 to the bottom, or we could just drop that and get rid of it. We could say that this converts to 4 to the 12th. It's much easier to see exactly which ones are greater now, which one's the least and which one's the greatest. So when we're putting this one in order, okay, we could say first we'd look at the number that's the least, which would be 4 to the negative 4th power, and then on the outside is 3. And then the second least would be, I'll change the color for the 4 to the negative 4th times 4 to the negative 5th. These are both the fractions that we had. Okay, and remember, with those fractions, even though it looks like 12 is greater than 9, it does mean that it's going to be a smaller fraction. Okay. And then the next one that we would have is 4 to the 15th power over 4 to the 5th power. And then last we would have 1 over 4 to the negative 12th. And I'm going to Put a shape around this so that we can see this clearly. And this would be how we would organize this from least to greatest.